Hi, I'm JD, and what we're going to be doing today is a hypothesis test for a mean. A study of college students going to the dentist was conducted, and their anxiety was measured on a scale from 0 being no anxiety to 20 being extreme anxiety. The summary statistics were collected from the scores of 25 students, and the summary statistics were the mean of the sample equals 10.5, and the standard deviation of the sample was equal to 3.7. Conduct a test of the hypothesis to determine whether the mean score for the population differs from the mean equaling 11. Use alpha equaling 0.05. Remember what your alpha is. Alpha is your significance level. It's also called it's the probability of getting a type 1 error. So if you would, pause the video and see if you can try to do this one on your own. Okay. So notice by looking at the problem that doesn't give you the standard deviation of the population. That means you have to use a t-test. Step 1 is always the same. You want to know what your null hypothesis and your alternative hypothesis. You also want to identify where the claim is at. And usually the claim will help you determine the null hypothesis or your alternative hypothesis. And they want you to test the hypothesis to determine whether the mean score for the population differs from mean equaling 11. So your alternative hypothesis would be your claim, and it's when it's not equal to 11. Label that as claim. And with my students and with some textbooks, how you do the null hypothesis differs. But here it's always going to be the same. Since this is not equal, this is going to be equal. The null hypothesis always includes equal, and the alternative hypothesis always does not include equal. So here it's not equal, this is equal. So step number 2 would be define your critical values. Now here, this gives you an idea on how to set it up. It's going to be a two-tailed test because this is not equal to. So you need to find your critical values. Now the catch with this is, since you don't have the standard deviation of the population, you have to use t-scores. So you need degrees of freedom. Your degrees of freedom here equals n minus 1. So in this problem, it would be 25 minus 1, which is 24. So that's 24. And then you need a table for your t-scores. Now, a table looks something like this. Now, this includes the area underneath the curve here. Now, since it's a two-tailed, what you want to do with your alpha is you want to split it. So this would be 0.025, and on this side it would be 0.025. I'm just taking this and I'm dividing it by 2. So I go back to my table. It tells me, okay, so alpha is 0.025. My degrees of freedom would be 24. I see where the 2 line up, which is 2.06 4. And you might have trouble seeing this on the video because it's really small. But it's 2.064. So 2.064. Now, like z-scores, t-scores are also, they're symmetrical, the curves. So what that means, if this is 2.064, then over here it's going to be a negative 2.064. Now let me erase some of this so we have room to put our test statistic. So I'm going to erase this and just put 24. Alright, step number 3 is you want to find your test statistic. So if here you're using t-scores, then you're going to use your test statistic is going to be t. So it's going to be a t-test. So t equals, and it's x bar minus mu over the standard deviation of the population, which is s, square root of n. And so you plug all those numbers in. They tell you that your x bar is 10.5. Your mu that you're testing is 11. Standard deviation, again from the word problem, is 3.7. And the sample size is 25. So it would be the square root of 25. Now plug that into your calculator. When you're plugging it into a calculator like this one right here, what you want to do is you want to put both the numerator and denominator inside the parentheses. It's going to separate it, and also you have to divide because the fraction bar means division. So plug everything in. So you have parentheses 10.5 minus 11 close parentheses divided by parentheses 3.7 divided by square root of 25. In this calculator, I have to close for the square root and then close for the denominator. And I get negative, and usually whatever the score is, like here it's the 3 decimal places, so I use 3 decimal places. So it would be negative 0.676. Alright, so step 4 is I need to make a decision. So step number 4, this falls right here. Remember, these are rejection regions. So when it doesn't fall in the rejection region, you do not reject the null hypothesis. So do not reject the null hypothesis. And then step 5, write your conclusion. And what's your conclusion here? Well, if you're not rejecting this, are you accepting this? Well, the answer is no, because you're still holding on to this. So your conclusion would be this: there is not enough evidence to support the claim And usually you would just restate it. I'm just going to say the claim that the means differ. Just going to shorten it. And that's it.